One of the most powerful tools that a circuit analyst has is to reduce a circuit down, to simplify the circuit by replacing more complex elements with simpler elements that are completely equivalent. Now, we have to be able to mathematically prove that they're completely equivalent, but fortunately, there are at least a couple of combinations that are very easy to prove and very easy to replace with simpler versions. The first of these is resistors in series. It turns out that if two resistors are in series with one another, it is very easy to replace them with an equivalent resistance that is exactly equivalent, exactly the same according to the rest of the circuit, according to the outside world. There is no change in the behavior of the circuit. So the question is, how can you identify two resistors that are in series? And the answer is, two resistors are in series with one another if every charge that flows through one resistor must also necessarily flow through the other one as well. Now, I don't mean that they have the same current going through them. It isn't sufficient that there's 2 amps in one and 2 amps in the other. I mean, literally, if an electron flows through the first resistor, it has no choice but to also flow through the second resistor. And you can see that here in figure 1. It's pretty apparent that if any charge flows through the top 5 ohm resistor, it has nowhere else to go. It can't build up here in between the two resistors. It can't escape out the side. It can't move into the paper or out of the paper. It must continue on and pass through the second resistor as well. And as a result of that, we can see that these two resistors are in series. Now, one of the most important skills that you can develop as a circuit analyst is to be able to recognize when resistors are in series, and as we're going to see in the next lesson, in parallel as well. But being able to recognize when they're in series is an essential skill. Now, there's a shortcut way to recognize when they're in series, and that is check to see if you can connect one end of the first resistor to either end of the second resistor, going only through wires, and this is very important, with no branching points. Because if there's a branching point in between those wires, then there's a possibility that an electron could escape and not pass through the second resistor. You can see here there are no branching points between these two resistors, and so therefore they're in series. You only have to connect one pair of ends. You don't have to connect both, just one. And so these resistors meet that criterion. Now this figure shows an example of a place where they do not. So here you can see the current flows through the top resistor has a choice. It can flow through the bottom resistor, or it can go down to the side through the 10 ohm resistor. Therefore, no resistors in this circuit are in series with one another. You cannot connect either end of this resistor to either end of this resistor, passing only through wires with no branching points. If you could, they would be in series, but you cannot, and therefore they are not. So what's the big deal? If you can identify two resistors that are in series, why does it really matter? We're going to show that we can combine those resistors together and replace two resistors, or even 3, or 4, or 50, with a single resistor. Here's a self-test. We've got an example circuit here that has 7 resistors. There are 2 pairs of these resistors that are in series with one another. So I look up here and I think, okay, well, is the 7 in series with the 8? No, because there's a branching point between them. Is the 6 in series with anything? No, because there's a branching point on either end of the 6 ohm resistor. So that kind of narrows it down. The 4 ohm and the 3 ohm are in series because you can connect them together with a wire with no branching points between them. And the 2 and the 5 are in series because you can connect them together with just a wire and no branching points between them. So you now have enough information to go and do the recognizing resistors in series example, but let's see what happens when we combine these resistors in series. So to combine 2 resistors in series, or more than 2 resistors in series, all you do is add their resistances. So this means that you can replace 2 or 3 or 10 resistors with a single resistor, and all you have to do is add their resistances. Now, I could show you the derivation of this. I don't think that you care, but it can be derived from Ohm's law and Kirchhoff's voltage law. You can find the derivation online or come and see your professor, and we'll be happy to show it to you. But the application of this rule is what matters the most. So when you replace 2 or more resistors in series, you just remove the old resistors and the wire that connected them, and then you connect the equivalent resistance between the 2 outermost terminals that remain. So whatever is left behind, there will be a skeleton of the circuit that's left behind. There will be 2 places where those resistors in series connect the equivalent resistance between them. So here you can see in figure A, this is an unusual circuit, and I've drawn it intentionally to be unusual. So you can see that the topology doesn't have to have the 2 resistors in line with one another. So I can see here that the 8 ohm resistor and the 2 ohm resistor are in series because you can connect them together using just a wire with no branching points. And when I pull the 8 ohm and the 2 ohm out, they're left behind the sort of stub of the wire here at the top and a stub of the wire here at the bottom. And so I can take the combination of those two resistors, 8 plus 2 gives 10 ohms, and I can take that 10 ohm resistor and I can put it here in between those two terminals. Now, is the 5 ohm in series with the 10 ohm? No, because there's a branching point in between them. And so given the information that we have right now, we can't simplify this circuit any further. So you now have enough information to learn about not only identifying resistors in series, but also combining them in series. I would encourage you to go do those two examples and then come back and we'll talk about resistors in parallel.